Hi and welcome to this On Maths prediction for the OCR GCSE Maths Paper 2 Foundation. Enjoy! Hi, I'm Chris Gilpin from On Maths. Now, what we do for this prediction is we take off all of the questions that came up in the Paper 1 and we look at the remaining topics and see how often they've come up before, both on the new GCSEs and on the old GCSEs, and we make a prediction. Now, like I said on the Paper 1 prediction, this is only used as part of your revision and not the sole purpose of your revision. So don't just look at this and leave it at that. However, as you might have seen with the Paper 1 questions, quite a few came up across the different exam boards, but our predictions get more and more accurate as we go on because obviously we now have seen the Paper 1, so you can make predictions for the Paper 2. All of our questions, all the questions you're going to see on this paper, you can do online on our website, onmaths.com. And if you go onto the website for free, you can either not sign up and just do the paper, and that's absolutely fine, or you can sign up and it will save your scores so you can try it multiple times, see if you can improve the scores. The onmaths.com also has topic busters, so you can practice every single topic. It also has demon questions for the harder style questions, and they're short little exams. They're only, I think, 20 marks, but they are just the toughest ones. And there's a whole load more things on the site. A new thing we're about to launch, so probably by the time you've seen this video, we have launched it, is the Revisionator. Now the Revisionator is only skills-based questions, so no difficult questions, we leave that for the demon questions. But what we've managed to do is take off all the topics that have previously come up and allow you just to revise a random selection of skills-based questions that might come up. So if you use the Revisionator, it will allow you just to focus on the topics that you need to focus on for the exam. So we're really excited to launch that. If you're watching this as soon as it comes out, it might not be launched yet, but hopefully it will be launched next week. So really looking forward to that. If you've got any questions or comments, please leave them in the comments tab below. If you like this video, please click like. And if you want to see more videos from us, especially the Paper 3 prediction, please click subscribe. I hope you enjoy. When we're asked to write a number in figures, it just means as numbers. So we've got 5,026. We need a 0 there as a placeholder. So you're just going to write 5026, 5026. Next question says, write down the value of 8. Now, if we remember, and let's just write the number a little bit bigger. This is our units column. This is our tenths column. And this is our hundredths column. So the value of the 8 is 8 hundredths. We can write that as a fraction, 8 hundredths. And that's the answer. Question C, write down 655 correct to the nearest 10. Okay, so 655, if we just do a quick number line, 655, the next 10 up is 660. And the next one down is 650. So those are the two it can round to. This 655 is bang on halfway, and if they are halfway, they round upwards. So the answer is 660. If I draw that properly. If it was any less, if it was 654, it would round down. So if the last number, if that number there is 5 or more, it will round up. Okay, for this question, we've got a ruler next to a line, and all we need to do is read off how long the line is, and it says the ruler is shown in centimetres. Now, a really common mistake with this is to write down 4.1. If I zoom in on that little bit there, at the end of the line, you can see that there are 4 little notches there. Now, the most important thing we work out with this question is what are each of those notches worth? So it's going to be 4.0 here and 5.0 here. Well, it's going to be, if we try 0.1, so we can try 4.1, 4.2, 4.3, 4.4, 4.5, so it's not going to work. So it's going to be 4.2, 4.4, 4.6, 4.8 and 5. So therefore they're going up in 0.2s, not 0.1s. So the answer is going to be 4.2, not 4.1. For this question, we need to understand the difference between multiples and factors. Multiples are just a numbers times table. So the multiples of 5 will be 5, 10, 15, 20, etc., etc. Now every number in the 5 times table ends in 0 or 5. So looking at the list of numbers we've got here, there's only one that ends in a 5 or a 0, which is 10. So 10 is a multiple of 5. Now factors go the other way. A factor of a number means that the number, so 24, is in another numbers times table. So 24, and the easiest way to find the factors of 24 is you start off with 1 and 24, because 1 times 24 is 24. Then you go 2 times, 12, 3 times 8, 4 times, and you think how many 4s? 6. 5 times, well that doesn't work. 6 times we've already got. So those 8 numbers are the factors of 24. Then I look at the list, well, already there's a 24 there. Is there any other ones I could have written? I don't see any other ones, so 24 is my answer there. 2 prime numbers. Now prime numbers mean they only have 2 factors, 1 and themselves. Okay, that's a prime number. If there's any more factors, it's not a prime number. So let's go through the list. 10 is in the 5 times table, which we identified in question A, so that's not a prime number. 24, well we've listed out 6 other factors of 24, so that's not in it. 18 is 3 times 6, so that's not going to be it. 17, I don't think of any times tables that 17 is in, so I'm going to say 17 is a prime number, which it is. And 19, well I can't think of any times tables 19 is in, so I think that's a prime number. Let's go through the rest to make sure. So 16 is 2 and 8, so that's not a prime number. And any even number apart from 2 is not going to be a prime number. 2 is the only even prime number. 27 looks like it might be, but actually 3 times 9 is 27, so it's definitely not. And 28 is another even number. So it looks like we found the 2 prime numbers. Now, I know it might seem a bit obvious, but it's really important in this question that we realise that 1 hour is 60 minutes. Now, the reason for that is it's really easy to accidentally think that there's 100 minutes in an hour. So 4 hours will be 4 times as much. 4 times 6 is 24 with a 0. Because it's 60, not 6. Now, a quarter of an hour, well, if you think about what half an hour is 30 minutes. And so a quarter of an hour is 15 minutes. So because this is 4 and a quarter hours, it's going to be 240 minutes plus another 15 minutes. So the answer is going to be 255 minutes. Okay, it's really important to realise the properties of all of the quadrilaterals. And we're given a piece of information here, which is one pair of opposite sides are parallel. So if I just draw that out, and I can just draw any set of parallel lines. Now it says one set of parallels, so I've got to make sure none other lines are parallel. There we go. And we know that looking at it now, is definitely a trapezium. And that's the only definition of a trapezium, is one pair of opposite sides are parallel, and obviously it's got 4 sides because it's quadrilateral. Okay, with these questions we've got to understand the rules of BIDMAS. So it's brackets first, then indices, then division, multiplication, addition, subtraction. So there's no brackets for this first one, but there is a division. So we've got to make sure we do the division first, and then we do the addition. So 55 divided by 5 is 11. and then 11 plus 7 is going to be 18. The next one, there's no brackets, indices, division, but there is a multiplication, so we need to do that bit first. So 3 plus 11 times 5 is 55, and so that's going to be 58. And it's really important to remember to do the multiplication first, because the most common wrong answer there is to do 14 times 5. Now next one, we've got to use our number line and understand the rules of negatives. Well, the first rule of the rule of negative we need here is when you've got an add and minus together, the minus wins. So minus 7, and it's going to become minus 2. And then we just use our number line. So we go to minus 7 on the number line, and we go left 2, 1, 2. So that would be minus 9. So the answer to that is minus 9. And the last one, the rule of negatives we need to know is that when you have two negatives together, it turns into a plus. So if I write the right number, so it's going to be 2 plus 15, which is 17. So the first thing to look at in this question is how many sides has the spinner got? So we've got 1, 2, 3, 4 equally sized, equally spaced out sides of that spinner. So any one of those colours is going to be a quarter chance. So let's have a look. What letter on the probability line represents a probability the spinner will land on a yellow? So there is one yellow on that spinner, and so therefore it's going to be a quarter chance. So if you have a look at how many notches this number line has, well, we don't count the first one, so we've got 1, 2, 3, 4 notches. So each one of those notches is going to be a quarter. So 1 quarter will be at B. Which letter represents probability of landing on a red? So we have 2 reds there. So that's going to be 2 quarters. So we've got 1 quarter and 2 quarters would be at C. Now 2 quarters is the same as a half, which is what the 0.5 there is. It's just a half. What letter on the probability line represents the probability it will land on a blue? Well, there aren't any blues on there. So however many times you spin it, it will never land on a blue. And in probability, we mark that with a 0. So it's going to be A. Okay, so this question is about coordinates. And the biggest mistakes with coordinates is getting them the wrong way around. So point A, which is this one here, it's either going to be 2, 1 or 1, 2. And the way of remembering it is you always go across first and then up. You go along the corridor, up the stairs. Okay, so you always read off the x-axis and then the y-axis. So the coordinate is 2 because we go 2 to the right from the middle, and 1 because we go 1 up. Now coordinate B is the same, so we're going along the corridor to minus 2, and then up 3. So along 2, or we'll go to the left 2 and up 3. Okay, it's asked us for which coordinate is at a point minus 2, minus 3. So we're going across to minus 2 again, but this time we're going minus 3, which means down 3. So it's going to be coordinate C, because C is at minus 2, minus 3. Okay, so we're asked which 2 points on the line y equals minus 2. So we've got to understand what y equals minus 2 is first. Y equals minus 2 is a line where y is always minus 2. Well, we know y is minus 2 here, but also y is minus 2 here, and actually anywhere across this line. And we call that line y equals minus 2, because y is always minus 2 along it. If you have a y equals line, it'll always go from left to right. If you have an x equals line, it'll always go from top to bottom. So the two coordinates on that line are D and E. So the 2 points on the line are D and E. When you're rounding numbers to significant figures, first of all write out the number. And with significant figures, you want to draw a line after the second number. So the 6 is the first number, the 3 is the second number. Now, unlike decimal places, you're not looking at counting from the decimal point. You're counting from the start of the number, and we'll have a look at an exception to that on question B. Then we look at this number. Now this number and the 2 are doomed. They're gone. But they're not quite done yet. That blue one has to make a decision. If that number is a 5 or more, that 3 will go up by 1. If it's less than 5, that 3 will stay the same. Now because it's less than 5, that 3 will stay the same. But have a think about it. If 6,312 people visited or were at a football match and someone said, oh, can you tell me roughly how many that was? If you said 63, that doesn't make any kind of sense. So the mistake that I've made, and the mistake most people make with this question, is they forget that the 1 and the 2 don't disappear. They turn to 0. So the answer is 6,300. Now on question B, this is an exception that we've got to remember with significant figures. You don't start counting until you hit a number that's not a 0. So the first number is 5 and the second one is 2. So the line will go here. Then let's have a look at our decider number where it's 1 again, so it's less than 5. So we're going to have 0.052. Now I could put 0, 0 in here, but this time the numbers aren't actually affecting anything. Was before, the 2 zeros there were holding that 6 to 6,000 and the 3 to 300, so they were really important. The zeros here aren't actually changing the number at all, so we don't need to have them. So the answer is 0.052. So for this question we're asked to find the percentage of the shape that's shaded. So there are 4 sections in total and 2 of them are shaded. So as a fraction that would be 2 over 4. Well, we can halve top and bottom, so it's a half. And you can see there that half of that's shaded. So what is half as a percentage? Well, a whole as a percentage is 100%. So a half as a percentage is 50%. And if you didn't know that, you need to just practice knowing the main percentages. A tenth is 10%, a hundredth is 1%, and a quarter is 25%. Okay, the next question says what fraction is shaded. So we need to know 2 things. First of all, how many squares are shaded. So 1, 2, 3. So it'd be 3 over the total amount of squares. So there's 1, 2, 3, 4, 5, 6, 7, 8 squares. So the fraction is 3 over 8. For the next question, it says shade in a fifth of this shape. Well, there's 10 squares altogether, and we want to shade a fifth. So we need to find a fifth of 10. In other words, what's a fifth times 10? When you times something by a fraction, just divide it by the bottom of the fraction. So another way of writing that is 10 divided by 5, which is 2. A different way of thinking about this question is if you cut this shape up into 5 equal sections, those sections, the green sections, become a fifth. So if we want to shade 1/5, we just want to shade in one of those sections. And actually that's the amount of squares that our calculation just worked out. So it should be 2 squares. Now it doesn't have to be the 2 squares that I've shaded. As long as you've shaded in 2 squares, then you've answered the question. And the last question says write down the fractions there that are equivalent to a quarter. Well, a nice easy way of starting this question off is just write down things that are equivalent to a quarter. So what I'm going to do is I'm going to times top and bottom of this fraction by 2. So 2 over 8. So I've times them by 2. Then I'm going to times them by 3. So it would be 3 over 12. Then I'm going to times them both by 4, and I'm just looking at this original fraction here. I'm going to times them both by 4, so it would be 4 over 16. Then times them both by 5, 5 over 20. Now all those fractions are equivalent, which means the same as a quarter. So let's have a look at our list. Well, we've got 2 over 8 there, so it's that one. And we've got 5 over 20 there. So my answer is going to be fraction B and fraction C. The first thing to look at with a pictogram, which this is the key. Now the key tells us what each picture represents. So if you have a look at the key here, it says each circle represents 8 DVDs. Now that's the complete circle. So it says, what day are the most DVDs sold? Monday, Tuesday or Wednesday? Well, or you can always just look at which has the most shapes. Now Tuesday has 2, Wednesday has 1.5, but Monday has over 2 3/4. So it's definitely going to be Monday because it's got the most circles. Now, how many DVDs were sold on Tuesday? Well, if each circle represents 8, there's 8 there and there's 8 there. So we just need to add the 8s together, which makes 16. So 16 DVDs were sold on Tuesday. It says how many DVDs were sold on Monday? Well, you've got the 8 there and you've got the 8 there. Now we've got a bit of a problem here because it's not a complete 8. So we need to figure out how much each quarter is worth. Well, what do you times by 4 to get 8? Well, 2. Let's check to see if that works. So we've got 2 there, 2 there, 2 there, and an extra 2, which is actually missing on that one, would make 8. So that would work perfectly. So to find out a quarter of it, we just divide it by 4, which gives us 2. So we've got the 8s, because we've got 2 complete circles, and then we've got those 3 2s, so we've got another 6. So we just need to add on 6 to the 16. So 16 plus 6 is going to be 22. So that's going to be 22. Okay, let's have a look at the next question. On Thursday, 20 DVDs were sold. Show this information on a pictogram. So let's have a think how many circles that will be. So if I've put one circle down, that's 8. Well, we've still got enough left over. If I put another full circle down, that's 16. Now 16, let's try another one. Let's put another full circle down, and that gives us 24. So that would be too much. So we're going to have to go into those quarters. So we've got 16. How many more 2s do we need? So 16, that would give us 18, and that would give us 20. So we need 2 whole circles and then 2 quarters. So if I shade in, if I draw, then shade in, 2 whole circles, and then we've got 2 quarters left over, which is just a half. Let's just check that. What's half of 8? That would be 4. And what's 8 plus 8 plus 4? That gives us 20. So we know the answer is correct. So for the first question, when you're adding letters together, the answer will be a number and then that letter. So we've got 1, 2, 3, 4, 5. So it's going to be 5b. The most common wrong answer is b to the power of 5. Now that's wrong because that only happens when you times them together, when you multiply them together. So it's going to be 5b for the first one. Next one is 10 lots of f, and we're taking away 3 lots of the f. Well, how many f have we got left over? Well, 10 lots of it and take away 3 lots of it means we've got 7 lots of it left. When you're simplifying one like this, in algebra we just don't use the times sign, so this is quite a nice easy question, 10ab. Now the last one is like terms, so we've got 5x here, and we're adding 5x, and we've got a 3y here, and we're taking away a y. So when you add the 5x to the 5x, you get 10x, and when you've got 3y and you're taking away y, which is short for 1y, so we've got 3 y's, taking away 1y, we're left with 2y. Now you can't simplify that any further because they are not like terms. You can times them, but you can't add or subtract them. Okay, so in this question we see that a square has an area of 121 centimeters squared, and we're asked for the perimeter of the square. So the first thing I would do is do a quick little diagram of this square, and we know that the area is 121 centimeters squared. Okay, so I know it's a square, so therefore the width, or the base, and the height will be exactly the same. Okay, and I know to find area, I do this one times this one. So I know that x times x, or x squared, equals 121. And if I put my lines in, then I can square root both sides, and so x is 11. So I know that 11 times 11 is 121. Now the temptation is to think, right, I've got the answer 11, but it's asked for the perimeter of the square. So I know perimeter is the distance around the square, and each side is 11. So it's 11 plus 11 plus 11 plus 11, or 11 times 4, which is the perimeter, which is 44. So the answer is 44 centimeters. Whenever answering questions involving ratios, always just double check that you read the question, because here it might look like the total is £35, but if you read the question it says Adele and Bert received £35. Now, to do this question, we've got to first of all work out how much Adele and Bert are getting in the ratio, how many parts. So Adele gets 3 parts and Bert gets 2 parts. So A and B parts equals 3 for Adele and 2 for Bert. So that's 5 parts in total that they get. Now it says they receive £35, so we need to work out what 1 part is worth. So to find out what 1 part is worth, we do the £35 that theirs is worth, and we divide it by 5 because they have 5 parts in that ratio. 35 divided by 5 is 7. So 1 part is worth £7. Now Chris has 6 parts, so Chris, we're doing now, he has 6 parts. So we do 6 times the £7 that each of his parts are worth, so it's going to be £42. And it's really easy to make mistakes with ratios questions by not reading the question, so just make sure you double check that you understand what the question's asking. So we're told 1 kilogram of cheese costs £7.70. How much would 600 grams cost? Well, first of all, I'm going to have weight, mass, and price. And I'm just going to sort of split them down the middle. So the weight, well, 1 kilogram is not going to help us because this one's in grams, so I'm going to convert that to grams. So it's 1,000 grams. And I'm going to convert this into pence. So 770 pence. Okay, so I need to get to 600 grams. And so first of all, if I've got a calculator, I can do this a lot easier. But without a calculator, let's try. Well, I can first of all divide this by 10 to get it so that it's 100. So that's 100 grams. And that would be 77. And then what I can do is I can times these by 6 to get 600. Okay, so if you've got a calculator you can just type it in, but let's assume that you don't for this question. So we've got 77 times 6. 6 times 7 is 42, add a 0, 6 times 7 is 42, add them together. Probably don't need to do this, but anyway, I'll do it anyway. 264. So it's 462 pence, but in pounds it would be £4.62. Last thing, just check it makes sense. Well, we've got just over half, so therefore the price is just over half. So it looks good to me. Okay, for this question, we're asked to find the cost of the toffees and the fudges. Now, if we imagine that we had 2 toffees and 3 fudges, how would you work this out? Well, the cost would be 2 times 50p, and then we would add 3 times 70p. The problem is that 2 and 3 I've just made up, so that's not going to be the answer to this question. What it says, though, is that it wants toffees to be called T, and fudges, the amount of fudges to be called F. So instead of 2 toffees, we have T toffees. And instead of 3 fudges, we have F fudges. And in algebra, we always put the number before the letter and we don't show the times sign. So it's 50T plus 70F. Now be careful, it does want the cost in pence, but sometimes it wants it in pounds. So if it wants it in pounds, it'd be 0.5T plus 0.7F. So the answer is C equals 50T plus 70F. And that can be either way around. The rule to remember when you're dividing fractions is KFC. Keep the first fraction the same, flip the second fraction, and change the divide to a times. So I'm going to rewrite that. I'm going to keep the first fraction. I'm going to flip the second fraction. And I'm going to change the divide to a times. And then when you're timesing fractions, you times the top, so 1 times 7, and times the bottom, so 11 times 2. So it's 7 over 22. With any sequence, the first thing to check is whether it goes up by the same amount. Well, looking at this goes up by 1, this goes up by 3, so it's not going up by the same amount. This goes up by 4, this goes up by 7. But something you might notice is this goes up by 7, yet there's a 7 here. This one goes up by 4, and there's a 4 here. This goes up by 3, and there's a 3 here. This is what we call the Fibonacci sequence. So the Fibonacci sequence just starts off with 2 numbers, and then we add the previous 2 terms to get to the next term. So we'll add these 2 together to get to the next one. Then we add these 2 together to get to the next one. So to find the next one, we need to add the 11 and the 18 together. 18 plus 11 is going to be 29. So the next term is going to be the 29th term. Let's just check that's the 6th term. 1, 2, 3, 4, 5. So yes, that would be the 6th term, would be 29. Then we need to add the 18 and the 29 together. And when the numbers get big, if it's not on the calculator paper, you can just add them like this. So 9 plus 8 is 17, and that's going to be 3 plus 1, which is 4. So it's going to be 47. So the 7th term is going to be 47. So always just check that the sequence isn't a Fibonacci sequence before you start to panic and think, what is this sequence? Always check for a Fibonacci sequence. It was just that the previous 2 terms are added together to make the next term. So this graph is showing how much a taxi charges against the distance travelled, and it asks us to interpret the y-intercept of the graph. Now the y-intercept is going to be this point here. If you notice, this is the point and when the distance is 0. In fact, the y-intercept is always when this thing here, which in this example is distance, is 0. So if you think about that in terms of hiring a taxi, that's how much you're charged before the taxi even travels anywhere. So sometimes we call it a standing charge or an initial charge. So the initial charge is, and then read off what it is, where it's £5. Okay, so in this question we're on a school trip, and it's best to break this question down into bits we need to work out. So it says 4 buses each carry 105 students. So the first thing I need to work out is how many students there are in total. It says 35% of the students are bringing their own lunch, so we don't need to worry too much about those students. A 1/7 of the students are buying lunch when they get to the theme park, and the question just basically says how many have not made plans for lunch. Okay, so find out how many students have not made plans for lunch. So they're not bringing their own lunch and they're not planning to buy lunch there. So let's do the first thing first, and let's work out the total total amount of students, and show the examiner what you're working out each time. So we're going to do 105 times by 4. You can do that any method you want, but it's going to be 100 times 4 is 400, 5 times 4 is 20, so it's going to be 420 students. So we've got 420 students in total. So next we need to work out how many are bringing their own lunch. So bringing lunch. Okay, so to do this, we're going to work out 10% first, which is going to be 42. Because if 100% is 420, that's how many students we have. 10% is you just divide it by 10. And next we can work out 5%, which is going to be half of that, so it's just going to be 21. Next we need to work out 30% because we need 35%. And all we do is times the 10% by 3. And again, I could do a bit of working out for this. So 42 times by 3. And you can use any method you want. A lot of you probably prefer doing the grid, which is absolutely fine. So 40 and 2 and 3. Obviously, if it's on the calculator paper, you can obviously just use a calculator. But either way, you get 126. So it's going to be 126. Now 35 would be these two added together. So it's going to be these two added together, because 5 plus 30 is 35. So 35% is going to be, and I can do a bit of working out here, so 126 plus 21, or the other way around, 741, so 147. Okay, so 147 students are bringing lunch. Next, so buying at park. So students who are buying at the theme park, it says a seventh of the students. So to find a seventh, all we do is we get the amount of students, which is 420, and we just divide it by 7. And again, you can do this any way you feel comfortable doing, although this is a bit easy because 42 divided by 7 we know is going to be 6. So 7s into 4 don't go, so carry that on. 7s into 42 are 6, 7s into 0 is 0. So it's going to be 60. So students left. So we're going to do the amount of students, which is 420, take away the people who are bringing lunch, plus the people who are buying it in the park. So we need to work out what that is. So it's 147 plus 60. So 7 plus 0 is 7. That's going to be 10. And so that's going to be 207. And finally we need to work that out. So 420 take away 207. So you can't do 0 take away 7, so we nick 1 there. 10 take away 7 is 3. We need to nick 1 there as well. So 11 take away 0. Oh no, I don't need to nick 1 there, do I? So we've just got 1, so that's 1. 4 take away 2 is 2. So the answer is 213. Now it's really important that you set your work out really logically. Any working out you do, try and keep it near where you've done done the calculation, written the calculation down. So I'd probably put this down here if I had like a piece of paper in front of me. Obviously I've moved these around slightly just to make them a bit clearer, so I'm not constantly scrolling. The headings are really helpful. So as an examiner, if you've headed all of your working out, it's really easy to spot what you've done and give you credit for it. So just make sure you set out your working out neatly and logically. Okay, so for this question, we've basically got the mean of the numbers. We know what 3 of them are, but we don't know what the 4th one is because the numbers rubbed off. Okay, so first thing for this question is think about how you would work out the mean. You'd work out the mean by adding these numbers together and then getting the answer and dividing by the amount of numbers we've got, which is 4. And we know that equals 12. So if I put an algebra letter in, so let's call it x, then I can write that down. So 9 plus 6 plus 15 plus x, which is our unknown, divided by 4 equals 12. Okay. Now if I put my lines down and just try and solve it, First thing to do is I'm going to times both sides by 4 to get rid of that divide by 4. And I'm going to add these numbers together because we know what the answer to this is. So 15 plus 6 is 21, 21 plus 9 is 30. So 30 plus x, and we've got rid of the divide by 4 because we've timesed it by 4, equals, and then 12 times 4, which is 48. Okay, next thing to do is take away that 30. So we've got x equals 18. So I know the answer is 18, but I can check that, just to check whether I've got it right. So 9 plus 6 plus 15 plus 18 is going to be 48. 48 divided by the amount of numbers, which is 4. So 48 divided by 4 is 12. So that's my answer. Now, you could have done that through just trying different numbers out, but imagine in the exam, maybe the numbers are going to be a lot bigger. So this method is probably the quickest, but there are other methods, other ways of doing it. At first glance, this seems like a really easy question. It seems like the answer will just be 80. But we've got to understand the way that bearings are written out. It says work out the bearing of A from B. It means that we are at B and we're trying to find where A is in relation to B. So the actual question is asking you for this angle here. Now don't forget, bearings are the angle going clockwise from north. So not so easy. The first step of doing this, and there are different ways of doing this, is just draw a line. In fact, I'll use my straight line one. Just draw a line straight down at B. If I can get it right, there we go. Now, north lines are always going to be parallel, and we can use that to work out this angle here. This angle here will be the same as this angle here, because they're Z angles or alternate angles. So that's also going to be 80. We know this one is a straight line, so we know this is going to be 180 degrees. So all we need to do to work out the bearing is do 180 plus 80. And when you add them together, you get 260. So the bearing is going to be 260. Now there are other ways of doing it. You could have worked out this angle, because this angle and the 80 degrees over here are co-interior, interior, or allied angles, whichever one you want to call them. So they will add up to 180. So we know that one's going to be 100. And then what we could have done is 360 take away 100, because it's the full circle is going to be 360, and we don't want that 100 one. You'd also get 260. Okay, so this question looks a little bit complicated, in fact very complicated, but whenever you have this type of question where you've got different categories of people or items, the best method and the clearest method is to draw a quick two-way table, which I'm going to do now. So I'm going to draw a quick two-way table, and the options for the people are either they are male or they are female. We'll add a total column or a total row, and they either do maths, English, science, and again I'll add a total as well. Okay, so I can add some lines in as well. In fact, let's do a different colour to make it a bit clearer. Okay, the absolute total is 123. Okay, and we just go through and fill in the bits we do know. So 57 of the students are female. So 57 females. 15 of the 36 students who went to English were male. So there's 36 students who went to English, and 15 of them were male. 33 students went to science, and 29 males went to maths. So 29 males went to maths. Okay, what we asked for, so we're looking for the females who went to science. So if I highlight that, so females who went to science. So we're looking for this one here. Okay, so what you can do with this question is just try and fill out the bits that you can, right? So I'm going to start off with this top one here. Okay, and there's different ways of doing this. Now, if there's 123 students in total and 57 of them are female, then 66 of them will be male. Okay, because these two here have to add up to 123. Then if there's 66 males in total and 29 of them went to maths and 15 of them went to English, then that leaves 22 who went to science. And if there's 22 males who went to science and there's 33 people in total who went to science, then there's going to be 11 females who went to science. Now there's different ways of doing this question, and actually you didn't need to do a two-way table for this question. It's just a lot easier to check your answer, and I find it a lot quicker. So if you have this type of question, a two-way table is probably the way to go. Okay, so in this question we're given recipes for 12 biscuits, and that's going to be important. But we're also told that Fred wants to make 18 biscuits, complete the new list of ingredients, like the amounts of the ingredients. So I've got to somehow get from 12 to 18 by just timesing or dividing. So I can't really think of a way to get from 12 to 18 easily without a calculator directly. So what I'm going to do is I'm going to go to 6 first. I'm going to divide the 12 by 2, so halve it, and then I'm going to times the 6 by 3. And that will get me to 18. Now, some of you might think, well, why can't we just add 6? Proportion doesn't work with adding or subtracting. You've got to times or divide to keep everything into proportion. So what I'm going to do with each of these ingredients is I'm going to halve them to find out what the amounts for 6 biscuits are. And then I'm going to times them by 3 to find out the amounts for 18. So half the 84 would be 42. Half the 60 would be 30. Half the 24 would be 12. Half the 2 would be 1. And now, because we've got 12 biscuits here, and we've halved them to make 6, a different way of doing this is just adding them together. 12 plus 6 is 18. So instead of timesing the 42 by 3, I could just add it to the 84. So I could just do 84 plus 42, which would be 126. Again, 60 plus the 30, which is 90. 24 plus the 12, which is 36. And 2 plus the 1, which is 3. So the answers are 126, 90, 36, and 3. Okay, second part of the question says that we've got enough of every other ingredient, but only 1 kilogram of flour. Now, first thing to note here is that 1 kilogram is 1,000 grams. So that's really important to know for this. And we need 84 grams of, and I'm going to do my working up here, but normally in your exam, make sure you do it underneath the question. So we know that 84 grams gives us enough for 12 biscuits. So I want to work out how much 1 biscuit would be. So I'm going to divide both of those by 12, so that I can work out exactly how many biscuits I can make. So it's 84 and then divide it by 12, which you can do any method you want. The answer will be 7 grams. So 1 biscuit's going to be 7 grams. And now we've got 1,000 grams. So what we want to do now is we want to work out how many 7s there are in 1,000. So we need to do 1,000 divided by 7. And this isn't the only way of doing this. Now, to do 1,000 divided by 7, what you could do is just keep going through the 7 times table. You might start off with 7 times 100, which is 700, and keep going there. Or you might use the bus stop method. And there's loads of different ways of doing this question. So I'm going to use the bus stop method. 7s into 1 don't go, so that 1 carries on. 7s into 10 go once, and then we carry the 3. 17 to 30, well 5 times 7 is 35, and 4 times 7 is 28, so it's going to be 4 with 2 carried on. 17 to 20, well 7 times 3 is 21, 7 times 2 is 14, so it's going to be 2. Now we could carry on and push on the 6 remaining, but actually it just shows us that we've got 142 whole biscuits and then some biscuits left over at the end. So we're only interested in how many biscuits he can actually make, which would be 142, but he might have like some flour left over, but it wouldn't make a biscuit. So the answer is 142. So inequalities, what are they? They just mean instead of x equaling something, x is greater than or smaller than something. So x can normally have lots of different values. Now, this statement here is really important. Integer just means a whole number. So we know that x can't be a half, because that's not a whole number. Now, x says here x is greater than -7 and is less than or equal to 3. So when it asks you to write down all the numbers that that's true for, well, let's have a think. Well, if it's if it's greater than -7, then it can't be -7. It can't be equal to it. So it's going to be -6, -5, -4, -3, -2, -1, 0, 1, and 2. Now let's have a look at the other one. It says x can be less than or equal to 3. So that line there, if you look at it, that little line there, so if I do it a little bit bigger, the line that I've just drawn there says it can be 3. So we must include 3 in our answer. And that's how you get full marks. Now you probably will get 1 mark if you forget to put the 3 down or you put the -7 accidentally. Right, the next one I'm just going to write out a little bit bigger. Now the way we do this question is the same way as solving just a normal equation with an equals, but don't ever put an equals. There was an exam a few years ago that if you wrote an equals in it, they would give you 0 marks. So the first step is to expand the brackets. So I do smiles and rainbows, but if you've got another method, that's fine. I'll put a little line there to remind me to times it. So 5 times 3x is 15x. And 5 times -5 is -25. Now you could have divided both sides by 5 and that would have been fine. Next step is to get rid of this -25. And you must start with that. You can't get rid of the 15 first. So we're going to add 25 to both sides to get rid of that -25. So we're left with 15x on this side. And 35 plus 25 will be, well, 5 plus 35 is 40, 40 plus 20 is 60. Now to get rid of this times 15, we need to divide both sides by 15. So that will get rid of the 15 there. And how many 15s in 60? Well, 2 times 15 is 30, so it would be 4. Now be really careful not to accidentally put any equal signs in your answer, and especially this bit here. So it's x is greater than 4. Okay, so for this question, it's really common to take the wrong approach with this. For instance, the biggest wrong answer for this is to try and get from 6 to 4, so we can divide it by 3 and then double it. So we're going to divide the days by 3, which is 4, and then double that. So the most common wrong answer is 8 days. And I understand why people put that answer down, but think about it logically. 6 people take 12 days. 4 people, which is less, so you imagine there's a task and you've got 6 people and then you've got 4 people, okay? You'd expect it to take longer. So if it took 12 days before, it wouldn't suddenly take 8 days. Otherwise, why would people employ more people? Why would a foreman employ more builders if less is better? So we know that that's the wrong answer. How do we work out the correct answer? Well, there's a really simple way of thinking about this, and it's to think about this thing I'm just making up now called people days. So every job has an amount of people days. Okay, and to work out the amount of people days for this, you get the amount of people, which is 6, and you times it by the amount of days it takes, which is 12. So 6 times 12 is 72. So it's going to take 72 people days. So for instance, if we had one person, which we could have, it will take that one person 72 days. If we had 2 people, it would take them half of the 72. So it says we've got 4 people. So what we do is you get the amount of people days, which is 72, but we don't have one person anymore, we've got 4 people, so we're going to divide it by 4. Now an easy way to divide something by 4 is to halve it, then halve it again. So 72 divided by 2 is 36, then halve it again is 18. So the answer is 18 days. Now let's have a look and see if that's realistic. Well, it took 6 people 12 days, so 4 people, which is less, will take longer. So instead of 12 days, 18 days. Now there is an assumption we've made, and that's that all the people work or paint at the same rate. Now it could be that the 6 people we originally had were kind of lazy, not very good at painting, had other distractions, and the 4 people we had are amazing people at painting, and actually maybe they did take less time. Or it could be that it rained when the 6 people tried to do it, and it didn't rain when the 4 people tried to do it. Don't get too creative with your explanations. They're looking for just some understanding that this is what we call in maths a model for working stuff out, and it doesn't always work. Because whenever you're working with people, people are different. We're all different. We've each got our individual differences. So anything that says that the people might not work at the same rate, absolutely fine, we'll get you the mark. Now this question looks a bit complicated, but the easiest or best way of approaching it is kind of put the question to the back of your mind and just try and write down all of the angles and the reasons for them that you can. So the first one I'm going to label is this one. I know it's a right angle because angles on a straight line equal 180. So therefore I can work out this one here. Because there's a triangle there, one with 26 degrees, one with 90 degrees, we can take them away from 180, and that will give me, so let's do that now, and that will give me 64. And it's important to write down the reasons. So angle BCA equals 180 take away 90 plus 26 equals 64 degrees. Angles in triangle equal 180, and I'd write it in words for the Etre exam. Okay, next thing I realise is that the x here is equal to the angle here, so this is also x. So angle BAC equals x, and the reason for that is z angles, although you have to use the right word, just alternate angles. Okay, the next bit, if you have only used the diagram and not read the question, you're going to have real problems because you can't answer the next bit without reading the question. This bit here in the question is critical, the fact that AB is the same as AC, so that length there and that length there are equal. Now something we do know about isosceles triangles, which this is that bottom 2 angles are equal, they are the same. Therefore, the next bit I can write down is angle ABC is going to equal 64 degrees as well, ISOS, because it's an isosceles triangle. Now, we've got all of the angles, so we know that x plus the 64 at the bottom plus 64 on the right hand side, so 64 on the left hand side plus 64 on the right hand side, we've got the 64 there from the previous question, equal 180 degrees, because again angles in a triangle equal 180 degrees. Equal equal 180 degrees. So we can finish it off by solving it. So I put my lines down. So we add 64 and 64 together, which would be 128. So x plus 128 equals 180, and we're going to take away the 128 from both sides. So we do 180 take away 128, which is 52. Now this isn't the only way of doing this. There are other methods. You could have tried to find this angle here, and those of you who are really good with algebra can try and understand why x will always be twice the angle here. So that's a little bit more of a challenge for you if you want to do that. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. Okay, so this question's about an adult and 2 children. So we've got David Smith and 2 children. So there's 1 adult and 2 children. But the prices shown are not quite right because there's a discount. And there's a 5th off adult price and 30% off the child price. So let's work out the adult price first. So a 5th off. Well, first of all, let's work out a 5th of £70. So to work out a 5th, you can just divide 70 by 5. Now I know that 10 fives are 50 and 4 fives are 20, so that's going to be 14. So that's going to be £14 he gets off. So therefore the price will be the £70 take away the £14. So 70 take away 10 is 60, take away 4 is 56. So he's going to pay £56 himself. Let's do the child price. Okay, so it's 30% off the child price. So we want to do 30% of £37. Okay, let's do the equals down here to give us some room. Well, I know that 10% is going to be £3.70, and then I need to times that by 3. Okay, so I could just times it by 3. Let's have a think. I could do 370. I could do it in pence, and then just times that by 3. So 370, and then I can just do times 3. So I can do a little grid. And if this is on the calculator, then obviously you just type it into the calculator. And obviously that's going to be 0, so we don't need that one. So that's 900. That's 21 with a 0. So 900 plus 21 210 even. 0, 1, and then 11. So that's going to be £11.10. And so we want to work out the price. So it's going to be £37. Take away £11.10. So if you take away 10 it's 27, take away 1 is 26, take away 10 is £25.90. Now that's for one child, so that's one child. So if I want two children, I want to do £25.90 times 2. Now I know 25 times 2 is 50, 90 times 2 is £1.80, so that's going to be £51.80. Okay, I'll move down a bit and let's do the total. So the total is going to be the adult price, which is this one here, plus the two children price, which is that one there. So I want to do 56 plus £51.80. And again, if you've got a calculator, you can just type it in, but let's do the column method. £1.80, and then people like putting the zeros in. So that's going to be 0, 8, 7, 10. So that's going to be £107.80. So it's £107.80. Finished. Okay, this question looks quite confusing because it says the weight of the sack is 19 kilograms, but then it asks you for the smallest and largest possible weight that it could be. So it seems quite confusing at first until we realise that it is rounded to the nearest kilogram. So the first diagram I draw out is just a line, and I put 19 in the middle. And I think to myself, right, what was the next one down that it could have been? If it wasn't 19, if it was less, what's the next one down it could have been? Well, the next one down would be 18. And then I think, well, what's the next one up it could be? Well, it could have been 20. It's not 18 or 20, it's 19. And then I think, well, what's the cutoff point between 18 and 19? So I draw a line down here, and the cutoff point would have been 18.5. So if it was 18.4, it would have been rounded to 18, but 18.5 or more, it's rounded to 19. And I do the same on the other side. So I draw a line between here and here, and this time I think, right, what's the cutoff point for this one? Well, that's 19.5. Now, this second one's a little bit more complicated because you might think, oh, actually 19.5 would round to 20. So it's 19.49 recurring. Yes, you would actually be true. Unfortunately, 19.49 recurring is actually the same as 19.5. So for our smallest possible weight, we put 18.5, and for the maximum possible weight, we can actually put 19.5, even though we know that would have rounded to 20. Now this works because it's a continuous scale. If you were doing an amount of counters, say if it was 19 counters, or I don't know, 190 counters to the nearest 10, then the lowest one would be 185, that would be fine. But the highest it could have been before it was rounded to the nearest 10 would be 194, because you can't get like a 0.1 of a counter. So just be wary of that if you're working in discrete calculation, so things that can't be 0.00001 or something, then you do like 4 at the end of it for the maximum. But if you're working with heights, weights, things like that, then 19.5 for this one is absolutely correct. Okay, I'm just going to write this out to make it a bit bigger. Now we're asked to make A the subject, which means we want A equals. So I'm going to put my lines down. Now the first thing I need to do is get rid of that square root, because if you look, the right hand side is all trapped in that square root. So what I'm going to do is square both sides. So we've got t squared equals, and when I square the square root, it just gets rid of the square root. Okay, next I need to get rid of that 3, so I'm going to take away 3 from both sides. So we've got t squared minus 3 equals 10a. Then I'm going to get rid of that 10. Now that's a times 10 there, so I need to divide both sides by 10. Now I could divide the t squared by 10 and the 3 by 10, or I can just write it as a fraction, which is a lot easier. So just put the whole thing over 10. So therefore a equals t squared minus 3 over 10. Now it's really important that if the letters are capitals, we keep them as capitals. If they're lowercase, we keep them as lowercase. It does matter what case the letters are, so if it's uppercase or lowercase. Okay, so the most important word in this question is this word here. As soon as you're asked to estimate something, it means you're going to round all of the numbers to normally one significant figure. There are a few exceptions like square roots where you round it to the nearest square number. So we're given this formula here, and we're given 4/3 times pi times r cubed. So what I need to do is write down what I'm rounding everything to first. So that pi, we know pi is 3.141 blah 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 blah. So I'm going to round that to 3, and I've done a mistake there. I've said equals, and what I should write is a kind of little squiggle equals, meaning roughly. Okay, and r is roughly, well it says radius is 3.22, so that's roughly 3 as well. So we're going to do 4/3 times pi, which we're saying is roughly 3, times 3 cubed. So when I do that, now if you notice, the divide, the over 3 there and through one of the 3's there will cancel. So we're going to do 4 times 3 cubed is 3 times 3, which is 9, times 3 is 27. And so we're going to do 4 times 27. So 4 times 27, which would be 4 times 7 plus 4 times 20, which is 108. Now there's a few things to notice. I could have rounded the 4/3 just to 1 and then just done 27 times 3. That would give me a slightly different answer, but that's still technically correct. You've just rounded the 4/3 to 1. They are quite liberal with what you round with these types of question. Pi is a nice easy one to round because that will always, for an estimation question, always round to 3. Now it says, is it an underestimate or overestimate? Well, pi was rounded up, so was rounded down. And the radius was rounded, well, it was 3.22 and we've rounded it down. So if you think about it, it's two numbers that are too small multiplied together, and one of those numbers is cubed, so it's going to be an underestimate. Now be careful, if there's a division in the question, you'll end up with a situation that it's going to be the opposite for the bottom number. So for instance, a over b, if we rounded b down, that would actually end up with a bigger number. So just be careful with division and subtraction with these, but when you're adding or multiplying, if you're rounding them both down, it will be an underestimate. Okay, for Venn diagrams, it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18, or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and. And it means it needs to be in A and B. It can't just be in A, it can't just be in B, it needs to be in both. And there's two numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are two numbers that fit that bill. So that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1/4, or a quarter. Now this question doesn't look like it gives us an awful lot to go on to answer it. However, it does give us enough. Remember, we're looking for an expression for the area of the triangle. So we're not looking for the actual number. We're looking for something like 5x squared or something. Okay, so most important thing to realise at the start is that m is the midpoint. And we need to start labelling the sides. So if the total height is 24x, then this bit here will be 12x. And this bit here will be 12x because m is a midpoint. Now, second most important thing to realise is it's a square. So the base and the height of the square are going to be equal. Therefore, it's going to be 24x across the bottom here. And we've used up an x at the top left bit. So we're going to have 23x left over. Okay, now, the way of doing these questions is you work out the area of the whole thing, okay, so the whole square. That's a dodgy looking square, but anyway, and you remove the bits that you don't want. Now the bits I don't want is that top triangle there, this bigger triangle here, and then the bottom triangle here, okay, and I can label them A, B and C. Okay, now I'm going to work out each of the triangles. So triangle A I'm going to start off with. So the area for triangle A is half times the base, which is x, times the height, which is 12x. Now x times x is x squared, and half of 12 is 6. That's going to be 6x squared. Triangle B, the area is going to be half times the base, which is 23x, times the height, which is 24x. So we know it's going to be x squared again, so the two x's, but I just need to do 23 times 24 times a half, or I can half 24 to make 12 and then times by 23, which is going to be 276x squared. Triangle C, okay, so same thing again, half times the base, which is 24x, times the height, which is 12x. And again, it's a very similar question to the one before. So we're going to do x times x, which is x squared, and we're going to do half times 24 times 12, or I could halve the 12 and then 12 times 12, sorry, half the 24 to make 12. 12 times 12 is 144. Okay, so the total area, so total triangles, is going to be 6x squared plus 276x squared plus 144x squared. So I'm going to add up all the bits we don't want, okay, which is 426x squared. Okay, so the bits we don't want is 426x squared. Now the total area is going to be the width of the square times the height of the square. Okay, so square area equals 24x times 24x. So the x and the x make x squared, and I've not left enough room there, and 24 times 24 is 576. Okay, so the shaded area is going to be the total square area, which is 576x squared. Take away the bits we don't want, which is 426x squared. So 576, take away 426, which is 150 x squared. So my answer is 150 x squared. Thank you very much for watching this video. Hopefully you found it useful. Don't forget you can go onto our website onmaths.com, which I'm sure the link will appear above me, to practice this paper and practice other papers as well. We've got all the previous year's predictions as well, which might be useful. And also we've got the new Revisionator coming out, so we're really excited. If you've enjoyed this video, please click like. If you want to see more from us, especially paper 3, please click subscribe. Thank you very much.